Hello, welcome to Topic 4 review. If this is 2021, you're on your E-Day. So here we go. Do me a big favor here, I'm giving all the answers. We got to go through 1 through 24 if this is the E-Day. So here we go. If not, this has everything. A triangle that is equilateral is also called equiangular, or you could call it regular. In the case of a triangle, if it's equilateral, that means all the sides are the same, then you can infer that all of the angles will also be the same. That works in a triangle only. It doesn't work in a quadrilateral, it doesn't work in a pentagon. It works in a triangle only. We call that a regular. If it has everything the same, all angles and all sides, it's called regular. So keep that in mind. Next, the angles of the triangle will sum to 180, not the sides. Not the sides. The sides have nothing to do with 180 degrees. It's the angles sum to 180. Next, the sum of the two adjacent interior angles. It's if you got a shape like this, these two in here will add to this one out here. The interior, and they have to be non-adjacent. It's not this one. This one is adjacent to here. It's these two on the other side. Some people call them remote interior because they're far away from that one. They will add to that. Next, the base angles of an isosceles triangle. If this is a leg, and that's a leg, and this is your base, the base angles will be congruent. Also, the legs will also be congruent. So you could actually put legs there and it'd be correct. Next, in a right triangle, if that's the right angle, this is your hypotenuse. This is your leg, and that's another leg. The legs make the right angle, the hypotenuse is the other piece, and it will always be the longest piece, because it's always going to be across from the longest angle, largest angle. A triangle with different measures is called scalene. If it has two the same, it's called isosceles. If it has all the same, it's called equilateral. So those are your options. The vertex is made by the legs. Up here again, this is the vertex made by the legs. And then lastly, an exterior angle makes a linear pair with an interior angle. Right here, these make a linear pair. An exterior angle makes a linear pair with that. Number 9, sometimes, always, or never. Let's do some more. By the way, I'm going way too fast, which means you need to pause and reflect as I go here. Pause and reflect, even reverse, rewind. All right, here we go. Two of the angles of a right triangle are never going to be supplementary means 180. All of the angles will be supplementary, and two of the angles, the two acute angles will be complementary. So like this one and this one in my right triangle have to add up to 90. And then all of them add up to 180. So be careful with your vocabulary there. So never, two of them are never supplementary. The two acute angles are always complementary, and all three angles together are supplementary, kind of. Number 10, the vertex angle is sometimes acute. You can make an isosceles triangle with an obtuse vertex, like this. Or you can make it like this with an acute vertex, or you can make it with a right vertex. Doesn't matter, you can do either one. Number 11, if one angle of an isosceles triangle is 60, let's try it. If you know that this is 60, then that's 60, and then using 180 degrees, that has to be 60. All right, so if you know that one angle is 60, then it's gonna be equiangular, which by default makes it equilateral. So that one ends up being always. You can have an obtuse scalene triangle. You can have a right scalene triangle, even an acute scalene triangle. It can sometimes have an obtuse angle. And then an isosceles triangle always has two congruent angles. It might actually have three, but it always has at least. This is actually a badly worded question. It always has at least two congruent angles. So we're going to say always there with an asterisk. Need to word that one better. All right, number 14. again, I'm going too fast. Pause, do the problem yourself, and then see how I do it. Solve for x. Well, according to these marks right here, it makes this an isosceles triangle, which makes this a leg, it makes this a leg, and it makes this the base, which makes this angle the same as this angle. Those are the same, which means that's 20x minus 10, and this also is 20x minus 10. Now I can take all of this and add it to 180 degrees. So angle plus angle plus angle equals 180 degrees. Work out the algebra, you will get x equals 4. Plug in the x equals 4, and you get 70, 70, and 40. Which means this is an acute triangle. All the angles are less than 90 degrees, so it makes it acute. Therefore, we're going to call this an acute isosceles triangle. It's acute isosceles. Number 15. It's just supposed to be triangles here. I don't know, my word didn't say that right or something, but triangle CJW is congruent to triangle AGS. So now I just wrote a couple triangles and I labeled it. That's 45. It's 50. Now because they correspond, J and G correspond, these would be the same. So I brought 45 over to here as well. I labeled S, and now we can say all three angles add to 180 degrees. Solve for x. Here you go. Number 16. We get info that the triangle is isosceles, which means I can go over to my picture and I can put the base angles equal, and I can make these marks as well because of the isosceles. So that gives me quite a bit of information. Knowing that it's isosceles, I get quite a bit of info. T is the midpoint of LN. So LN right here is being bisected by T. Midpoint means it's in the middle. So I can put that mark and that mark. Gives me a little bit. And then I also have this shared side. So I got that mark here as well. So there's actually a lot of info here. To prove that this triangle is the same as this triangle, I can use side, 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 or I can use side, angle, side. That's what I have right now. So you could use that or that. Now, once it is known that the triangles are congruent, then you could also conclude that one's congruent to two because those M and M, the M's correspond. The angles would correspond, corresponding parts. Number 17. What I did was I took these two triangles that I'm looking at and I drew pictures. PQR versus STU. I made them correspond. I labeled my information, and then it says what other information is necessary to be able to use angle, side, angle. So we have angle, side, angle. Angle, side, angle. We need this side to be the same as this side. You can even put the marks there if you want, but that's what we're looking for right here. We need PR to be congruent to SU. This will be a multiple choice question. You'll have different options. You gotta click, you gotta pick this one, not click, as your multiple choice. All right, next one, same triangles, PQR and STU, same triangles, different information. We have Q and T, we have PQ and ST, and we need another piece of information to use angle, angle, side. So I want to not do this angle because that would give me angle, side, angle. I want to do this one. I want to do why did I say that? That's not right. I want angle R is congruent to angle U. There we go. Bam. Got it. That would give me angle, angle, side. All right, on to the next page. Don't forget the exterior angle theorem, which says if I take these two inside angles, it will add up to the outside angle. Don't forget that. The two interiors add to the exterior. which is why I can just say this is 30. 30 plus 30 has to equal 60. Over here, do the same thing. The two interiors will add up to the exteriors. That's why I did that plus that equals 154. That plus that equals 154. Solve it, you get x equals 12. Next question. Which additional piece of information, if we're going to use HL? Well, in this triangle, that's the hypotenuse, that's a leg, and that's a leg. That's the hypotenuse, that's a leg, and that's... How did I know? Because the hypotenuse is always opposite of the right angle. Opposites. So basically, I just need to mark another set of legs. And it looks like this leg is probably going to match up with that leg. So you could say SQ is congruent to XZ. That would work. Or you could use the other legs and say that. Either one works. Do you understand the difference between a leg and a hypotenuse in a right triangle? Ask yourself. Study the problem if you don't. The next one, there are multiple answers to this, but this is just one of them. If I start with RQM, I like to just do 1 mark, 2 mark, 3 mark in the triangle. Then this triangle would be 1 mark, 2 mark, 3 mark. That would be QRS. So RQM would match up with QRS. In this problem, we have a S, and we have a set of angles, and that is all we have. We do not have enough info to make the triangles congruent. We would either need another set of sides and do side, angle, side, or that's our only option. 24. Mark the congruent right angles. We now have angle, angle, side. If it was this side marked, that would be angle, side, angle, but we do not have the included side, so it's angle, angle, side. 25. Puzzles. Try them yourself first, but here we go. We can do vertical angles here. We can do 180 here. We can do 180 here. Nice straight line. And then we can do 180 here. 26. We can do vertical here. We can do 180 here. We can do a linear pair here, so 180 here. We can do 180, linear pair here. And then we can do 180 for the triangle. 27. We have isosceles triangles. So start with 180, take away 118, you get 62. There's 62 degrees left to split. You have to split it evenly, so 31 and 31. Vertical angles makes this 31. Isosceles triangle again makes this 31. 180 degrees makes this 118, and a linear pair makes this 62. 28. Linear pair makes this 60. Isosceles makes both of these 60. 180 degrees makes this one 60. 90 degrees makes this one 30. And linear pair makes 180 degrees, so it makes this one 150. All right, on to the last page here. 29. Can 4, 7, and 10 make a triangle? Yes, because the two smallest sides add up to be bigger than the third side. So 4 plus 7 is bigger than 10. So it works. That's what has to happen. Is 2 plus 9 bigger than 12? No. Is what's these two? 14 plus 18 bigger than 32? No. It's equal. Equal is not bigger. That is an equal sign, by the way. Come on, Smitty. Equal. Make that more clear. What about these? Are the two smallest sides, when you add them together, bigger than the third side? Yes. It's like 104 point something when you add these together. So it is bigger than 103. Just barely, but it is. So it is yes. All right, 33. Name the longest side. Well, I can tell you that this is the largest angle. So that makes this the longest side. It's the one that's not connected. This is connected to 70. This is connected to 70. This one's on the other side. Name the angle with the greatest measure. Well, 9 is the biggest side, so that makes I the biggest measure. Oh, end of day, here we go.
Good afternoon, I do have one announcement. Bell bowlers, please report to Mrs. J's room as soon as possible. Bell bowl will be immediately.
All right, here we go. In this problem, we'll just do you can do whatever proof technique you like. I'll do the 2-column here. They do give parallel, so watch out for those parallel. Anytime you get parallel, you're looking for a z, or you're looking for a, well, in this case, I'm going to use the corresponding angles. In this case, you could do a z on this one as well. It doesn't really matter, but here you go. I'm going to put in my givens. I compile and I conclude. This given counts as an S. I can make that mark and that mark. This given counts as an A. So I can make that mark and that mark. And the parallel lines lead to the corresponding angles. 1 and 2 are congruent. 1 and 2 have to be congruent because they're corresponding in these two triangles. So that leads us to that mark and that mark, which is angle side angle. So I'm going to make my conclusion with angle side angle a check. Angle, there's another angle, and there's a side. Check my work. Next one's a little bit more tricky. All right, here we go. As given, C is the midpoint between B and D. So that makes this the same as that. So I said C is the midpoint of B, which implies this is the same as that by the definition of midpoint. That is an S. Let me write it over here. That's an S. Also, we have another given, the perpendicular givens, which means B and D are both right angles. That's what perpendicular means, and therefore B is congruent to D because all right angles are congruent. So that is an A in my problem. I've compiled an A. I got an S, and I've got an A. S and an A. Lastly, or also, this angle is congruent to that angle. I can go in here and do the vertical angles, which counts as another A. Therefore, I've compiled enough information, I've given good reason to conclude by angle side angle. All right, last one. I'm just going to leave it open to you guys, but BA is congruent to ED. That's that and that. That's an S. C is the midpoint of both of these. So that means this is the same as that. And it means that's the same as that because it's a midpoint of both segments. And so you're going to compile, use the definition of midpoint, and conclude with SSS. You can do a paragraph or a 2-column, your choice. All right, that is the end of chapter 4, topic 4. Have a good E-day.